Grams law of diffusion. Let's simplify the formula so that next time we can actually take one or two questions from using the formula. So in grams law of diffusion, we have R1 all over R2 is equal to square root M2 all over M1. So they actually try to compare the rates of diffusion of two gases based on this square root of the relative molecular masses. So where problem often come in this question is not looking for R2. R1 is actually the rate of diffusion of the first gas, while R2 is the rate of diffusion of second gas. M2 is atomic mass of the second gas, and M1 is atomic mass of the first gas. Whenever I'm looking for R2, it's really simple because you can easily say R2 is equal to R1 multiplied by square root of M2 all over M1. Everybody knows this. So it's actually very simple. Where the problem often comes is whenever I'm looking for something inside the bracket, which is sometimes M2 or D2. Now D2 is densities, while M2 is relative molecular mass, atomic mass. So looking for M2, you have to remove this square root. And if you are removing the square root, because looking for M2, your formula will now be rearranged as R1 all over R2 square multiplied by M1. Why? When you remove square root from this side, you have to bring it around square it because square root is the opposite of square. So if you say the square root of 16 is 4, Abi, and the 4 square is what? 16. So you see, square root is the inverse of square. So you remove the square root from this side and bring it to this side, and that is also what we did. We removed this from this side in order to take this, and we brought it to this side, and that was how we got this. So that is just it. It's very simple as that. Now, sometimes the question might come as R1 all over R2 is equal to square root D2 all over D1. You can still use the same method to solve it. It's still the same thing. Looking for R2, you use this method. Looking for D2, you can still use this method. It will still work for you. Now, but if you are working with time, if you're dealing with time, because it's only rate versus density, if you're dealing with time, then you have to remember that R rate is the reciprocal of what? Of time. So what does it mean? It simply means that as when something is done at a faster rate, then that means the time required is what? Is small. And when something is done at a slower rate, that means it actually requires a longer time. Therefore, where R1 is, where R1 is where T2 is, and where R2 is where T1 is. Now, since this goes this way, then you come back to this formula, which is T2 all over T1 is equal to square root M2 all over M1. You see, it has changed. Now, if you are looking for M2, you now say M2 will now be equal to what? T2 all over T1 square multiplied by M1. See, this is where the wahala normally comes. So people will just, use the same R1 method by saying T1 over T2. You definitely get wrong answer. Definitely. Even some textbooks, you see them making this mistake. Where they should put T2, they will go and put R1. They will go and put T1 there and bring T2 this place. You will definitely make mistake. So it has to be what? T2 all over T1, unlike R1 all over R2. Now, there are still some cases where you can look for R1 by saying R1 is equal to V1 all over T1 and R2 is equal to V2 all over T2. So this method is also I've seen a question that required this formula in JAM. So it was as simple as that. So So these are various ways you can use this formula to solve any transformation form. If you are looking for R2, which is the rate of the second gas, you use R2 equals to R1 multiplied by M followed by M1. If you are looking for M2, which is inside the square roots, then you have to remove the square roots and bring it this side by squaring it. So it becomes M2 equal to R1 over R2 square multiplied by M1. The same method apply for density. Now if you're looking for T2, T, because R is the reciprocal of time, where R1 is where T2 should be. And where R2 is where T1 should be. Therefore, we'll come back to this formula and say T2. Instead of R1, we say T2 all over T1 equal to this. So we're looking for this becomes T2 all over T1 multiplied by M1. So that is just it. You can also apply this based on how the question is coming. When next we meet, we'll take questions that has to involve any of these formulas to see how we can do it. Please do like, comment, and share our online class.